This app, created by MonaRk, can explore flight path variations within routes, see if weather was the reason for these variations, and calculate the cost of these variations compared to the shortest path taken. Use this table to compare and select routes. The first one is San Diego to Sacramento in North America. In this dataset, we have 472 flight paths for this one route. Note that the data in this app is from Mondays only in UTC time, starting September 30th, 2019. Only flight paths that contain a location break of no more than 30 minutes are included since we want to compare complete flight paths. Therefore, we won't see intercontinental flights like from JFK to London Heathrow in this data. Using backspace to clear the filter, we can go back to the first route and we see no Airbus aircraft are used. Click this checkbox to show paths with Airbus aircraft only. It will reset the sorting and filters of the table. The rest of the app will only use these Airbus paths, so keep that in mind when comparing total costs. It will be a lot lower than the total for all manufacturers. Next, let's filter the percent of paths that overlap a segment report and the average duration to get rid of extremes. Remember to clear a selection if you've already selected some routes and they are filtered away. They will be included if they are selected and no longer showing on the table. We could also sort and filter by the percentage of flights with a segment within 1,000 kilometers, the percentage of flights that overlap a storm event, which is a US-only weather database, the percentage of flights that experience any weather delay or national airspace delays. NAS delays are often also caused by weather. Now that we've filtered, let's sort by continent and select one route from each continent. As we've mentioned before, there aren't any African flights because the data coverage is low, and this app is limited to routes that have at least 50 flights. Click Compare Selected Routes, wait for the progress bar to fill and the success message to appear here. On the next tab, we can compare duration and distance of the flights within the routes. One thing that we can see with these routes is that the European route has the lowest distance, but not the lowest duration on average. Minute and kilometer increases for a flight are calculated by comparing it to the shortest observed flight in the route. We can also see the European flight has a higher average percent distance and duration increase. The colors of the plots can be changed to reflect other weather variables. Just keep in mind, 3 are only for US data. The colors themselves can be changed too. Any of these plots can be downloaded as an SVG. On the next tab, wait a few seconds for the map to load. The map and the plots on this page show a subset of flights due to data size restrictions. Only the shortest route by duration, the shortest route by distance, and the 30 longest routes by duration and 30 longest by distance are shown. There's likely a lot of overlap here, so less than 62 routes are showing. Click on routes to highlight them across the plots and get more information in the pop-ups. Segments happening during the time of the route within 1,000 kilometers are shown on the map. Draw a rectangle to zoom in on the plots and use the controls at the top to reset. These plots can be downloaded as SVGs. Again, the color can be changed to reflect a different weather variable, and you can change the displayed route. You can also download the map as a PDF. It takes about 15 seconds. A quirk about the map download is that the PDF doesn't accurately reflect transparent colors. You'll have to change the colors to opaque or open the temp.html file within the app directory and take a screenshot. The last tab shows the estimated extra cost per flight due to those deviations we saw on the map. Again, we can change the colors at the bottom of the page and download the plots. We can see for that European flight, the average extra cost is around $800, and on the next plot, the total extra cost for all those flights is over $200,000. The total extra cost for the weather-affected flights is less than for the weather-unaffected, but since there are fewer weather-affected flights, the averages tell a different story. These figures here show that on average, a weather-affected flight is $200 more than a normal flight. Then we can look at the table to see the total extension costs. For example, for all North American flights in the data across 39 Mondays, the total extension cost is $103 million, since we have 186,000 flights with the average extension cost of $552. Only 10% of the North American flights have a segment overlap, but 13.3% of the extension costs come from these 10% of flights. The all continents row is the summer average of all the data we have. Since there is about 100,000 flights per day, but we can only collect the full data for 11,000 flights per day. The last row is a rough times 9 calculation to estimate the total extension costs for all flights worldwide. You might be asking, how are those costs calculated? Well, you actually have control over it. Now, each hour is said to cost $2,500, but we can change this to the cost per extra kilometer, give different costs to the continents. For example, maybe Asia should be more expensive. Remember, too, that this is only Monday data, so we can extrapolate to all days of the week, which executes a rough times 7 calculation on the total costs. We can choose the date range, perhaps to exclude coronavirus. Click the Update button, and we can see that this cost is calculated by distance. Asia is proportionally more expensive. The totals are 7 times what they would be for just the Monday data, and the data is shown for 5 months. The changes that you make to the cost inputs are reflected on the Map tab. The last interesting thing to look at is the proportion of weather-affected flights for each continent, and see that the cost from these flights is proportionally higher for almost every continent.